Okay, I'm going to look at integration. So if you've got your C and notes up, then I have got them condensed down here. So basically, the first thing, this lesson is all about the introduction of integration. What is it? It's the reverse of differentiation. Okay, so let's remember what we know. If you had y equals 2x squared plus 3x plus 6, and you had to differentiate that, you would bring the power to the front and take 1 off. X disappears, and so does the 4. So when you're integrating it, you do everything in reverse. So the way you bring the power to the front and take 1 off. So instead of taking 1 off to the power, we're going to add 1. So add 1 to the power. Instead of bringing it to the front and multiplying, we divide by it. So that's a complete reverse. Now here, remember x disappeared. So if you have a number on its own, the x will reappear. Okay? And you see the way the constant here, this 4 on its own, disappeared. Well, it's going to reappear. But the only problem is, I don't know what it's going to reappear as. I need extra information to help me find what it's going to reappear as. So what we do is we normally just put down plus c, and c stands for any constant that may have disappeared. Okay, that probably sounds really complicated. Let's go through these few wee examples that I have first, and then we'll talk about this constant. So if you've got dy by dx equals x3, to integrate that, to go backwards, you add 1 and divide by it, and put plus c, because there may have been a number that disappeared when you differentiate it, so it reappears when you integrate, so just put plus c. If you look at this one, dy by dx was x6, so if you're going backwards, add 1, divide by it, and put plus c. This one here, x to the power of 1, add 1, x squared over and divide by it, don't forget your c. So this c, we'll see it later on how we can actually find it, but at the minute, all you're doing is just putting plus c. So here's your dy by dx, you want to integrate that. So you add 1 to the power and divide by it, don't forget your c. X to the 4, add 1, so it's x to the 5, and divide by it, and don't forget c. Now, just watch this wee one. Do you remember when you differentiate it up here? When you differentiate it, the x disappeared. So when you're integrating, if you've got a number on its own, the x is going to reappear. But don't forget to put plus c. So the basic rules, add 1 to the power and divide by it. If you've got a number on its own, the x will reappear. And always put plus c at the end. And that's what this is saying. So add 1 to the power, divide by it, and don't forget your c. Right, what's all this mean? See this like stretched out s and this dx? That means you're integrating what's in the middle. You're integrating the xn. So you add 1, divide by it, don't forget c. So if I look at this here example, this is telling me I'm integrating, and dx is telling me what is doing the integration. So everything in between this, where my fingers are, is integrating. Sometimes people put brackets around it. I'm very bad at putting brackets in. It doesn't really matter, so it doesn't. So let's see, add 1, divide by it. Remember that's the power of 1, add 1, so you get 3 squared, divide by it. The x will reappear, so that's 2x, don't forget your c. That's it. Let's look at part 2. So the integrate 4x squared minus 5x minus 1 dx. So in here is what you're integrating. Add 1, 4x3, divide by it. Remember that's x1. So add 1 to that, so it's minus 5x2, divide by it. Now do you remember what happened here? That becomes minus 1x, and don't forget your c. You can always do a wee quick check to see if it's right. So if I take this here line, and if I differentiate it, so power goes to front and multiply, and take 1 off. Power goes to front and multiply, take 1 off. X disappears, plus c. You should get right back to where you started from. Now, it can be very complicated going between differentiation and integration. My advice to you, if the question is integration, just integrate. If it's differentiation, just differentiate. Don't mix the two up. Okay, so just try to get your mindset into one or the other. This here question, I can't integrate that because it's in brackets. It has to just be a string of numbers and letters before I can integrate it. So I'm going to multiply out these brackets. So it's x squared minus 2x plus 3x minus 6. And just tidy up the middle there. So minus 2x adds 3x is 1x. Now I'm ready to integrate. Notice there I keep my integral sign and dx either side. They only disappear when I integrate. So So add 1, divide by it. That's x to the 1, add 1, you get x2, divide by it. The x reappears, so it's minus 6x, and don't forget the c. Okay, the next bit, part C, is going to check this last example actually. This is one we're going to actually be able to find c. So you've got dy by dx equals this. And the curve goes through this point. The curve is just what y is. So first of all, let's times this out. So dy by dx is 2x cubed add x squared. So if I want to get y, I'm going to integrate. So you add 1, divide by it. Add 1, divide by it, and don't forget your c. That is exactly the same as me writing. I could have written that like this. 2x cubed plus x squared dx. And then just done your integration from there. It's exactly the same. And you do sort of flip between the two methods, or two ways of writing it out, but as long as you're integrating, it doesn't matter. So, I've gone back to get my y, so let's tidy that up. So y is x4 over 2 plus x3 over 3 plus c. That's normally we finished it off, but you're told this curve goes through 1, 5. So when x is 1, y is 5. So just sub that in. So y is 5 when x is 1. And if you work that out, you'll get a value for c. So now you can rewrite your curve as y equals x4 over 2 plus x3 over 3 plus your c.